Hello, everyone. My name is Joris Peels, and this is another episode of our, work in progress, really. That's what this is. we're, so essentially what we're doing is, this is called the 3dprint.com's 3D Printing News Unpeeled and live with Joris Peels. And what we're trying to do is create a daily news roundup that would be the ideal one for you and the ideal one for you to listen to every day or most days. So it's a work in progress. So it's really up to you what this is, and we hope that you guys share this. We hope that you comment, and we hope that you give us ideas and things about what to change, what to do the same, that kind of thing. So we're really going to have a number of news items, different ones every day. Today we have five for you, and we're going to rank them from 5 to 1, for their potential to be disruptive, for the potential to be very interesting, or maybe even some things that maybe are a bit, unforeseen or unanticipated, or people really haven't noticed the impact of, or wouldn't really immediately realize the impact of. And that's kind of what we're hoping to do. So we have five news items today, as I stated before, and one of them, the number five, is Flashforge to focus on the enterprise material extrusion market. This is a story. So on this the roundup, we do stories not only that we've covered, but there was some other ones from other news sources. This one's from 3D printing industry. So essentially, what Flashforge is doing is transitioning from being a mainly desktop and home user focused business in the kind of like $1,500 price segment to making enterprise kind of printers, which is kind of at the moment they're focusing on the Creator 4, which is $12,000 IDEX independent dual extruder system that has a filament humidor cabinet, which is something that I wish I invented at least the terminology. We like this because it's news that we predicted. Like we went a long time ago, we've been talking about the consolidation in this market, but also like the fact that a lot of players will be pushed out of the lower end space and kind of, um, you know, voluntarily exit the lower end, like the $500 printers, but also the mid market to try to move more where the margins are and where the future seems to be, and that is in the enterprise. Um, XYZ printing has done this before. BCN 3D has done this. Ultimaker and MakerBot also did this by moving, from $2,500 to like $5,000 and over in price segment. What we're seeing is a really busy kind of high-end kind of pro space, and a significantly less busy kind of mid-market $2,000 3D printer space. So that's really interesting. I think there are a lot of people are seeding opportunities there that could be filled with other incumbents and players. And on the bottom end, we see like this Creality and Anet and the clone wars, let's say, happening. These companies and everyone crushing everyone else, and also Prusa Research doing a lot of work at the $300 and the $1,000 price point. So what we're seeing is that that these guys are automatically kind of moving into that territory. Now, does that mean that that's a good idea? Well, it depends really, because it's going to be really different to play in the enterprise space. You're going to need to do a lot more service. You're going to need to have higher end components. You're going to have to like work a little bit differently with people. So it remains to be seen who's going to do a good job of being an enterprise kind of pro 3D printer company. Also, at the same time, I think there's a lot more opportunities there. Think about like $1,000 really good printer for a print farm or for a university. There's a lot more opportunities, I think, out there than people focus on. So I think it's an interesting move. It's a really big trend. It really is kind of like something we should be paying attention to, because these guys are all going to want to move up. But so that was our fifth news item. The fourth news item is that Thales Alenia Space and Meprons are developing a water-powered satellite propulsion system. This is an article on 3dprint.com. Miniaturized high-thrust thruster will use hydrogen instead of hydrazine fuel. It'll essentially do an electrolysis process, which will split the water into hydrogen and oxygen and feed the hydrogen into the combustion chamber. The idea is that this will allow for faster maneuvering satellites. And the 3D printing element, of course, is that this thing is going to be made with 3D printing, and that this is going to enable that thing to be reduced mass as well. Now, from a cost perspective, what's also interesting is that they hope that this engine would be kind of modular, so they can make like a small one, or kind of like scale it up, and then for bigger satellites, and use essentially the same design to power lots of different sizes of satellites. At the moment, it's TRL 3 to 4. And it's joined by a bunch of other kind of like similar efforts, like the University of Tokyo had a spin out called Pale Blue, and NASA has a water-based propulsion system company spin-off called Hydros Thrusters. So this is significant because nearly all of the commercial space companies, a lot of the government players use 3D printing for propulsion for rockets to get to space. And the in-space propulsion market for satellites is set to grow thousands of percent. And so we hope that also that we will play a role in that in the future. It looks really very much that if the space industry continues to grow, that it may be the biggest market for 3D printing. And I think that's a very exciting thing as well, kind of having a home market. News item number 3. Ambots makes tiny car with swarm manufacturing. So Ambots is co-founded by Dr. Wenchao Zhu of the University of Arkansas, and they've essentially come up with a new manufacturing idea or paradigm. The idea is that they have general purpose factories. So rather than a special purpose factory, which is just geared to make one car, one model of car, maybe a small series of cars, a general purpose factory could be reconfigured very quickly, reprogrammed essentially to make lots and lots of different items and lots of different changes in the manufacturing setup could be done kind of almost instantaneously. Essentially, what it is the car that is to be printed stays in one place, and transport robots bring all sorts of 3D printers, laser cutters, pick and place robots, and components to that car. And the idea, of course, is that you could reconfigure this. You could make cars and blenders at the same time, that kind of thing. Now, we can talk, I think, a long time with a lot of automation people about whether this is the paradigm of the future. They would, for example, they do this on a grid floor type of setup at the moment, but be much, maybe they should do it with the robots hanging from the ceiling, for example. There's different ways of doing this, different ways of thinking if this is a good idea or not. But what I do like about it is that it offers a comprehensive vision to the future of manufacturing. This whole idea of like the resilience, making more with less material, using less energy, making things closer to the consumer, producing on demand, faster time to market, all those things could be solved in an Ambots kind of way. And in 3D printing, we're tied to kind of this industry 4.0 kind of thing in Europe, kind of the more the supply chain resilience, digital manufacturing idea in the United States. But we don't really have a comprehensive vision. We don't really have like something for lawmakers and things to buy into, besides just 3D printing as a technology of the future. So I think that's a thing to really, really think about. And that's why this is significant. And apart from this, I think it's really interesting in and of itself as well. So what am I going to do to top this is our second news item. That is essentially Eterna, which is spelled Eternaha. Eterna is 3D printing connectors for bracelets, as in the bracelets like jewelry for men and women. This is an article from TCT Magazine. It's about Italian bracelet brand Eterna, which is using powder bed fusion with WinForm PAGF, which is a glass-filled polyamide material that's developed by CRP technology and used extensively previously in kind of like automotive application and other things. The people from Eterna say our jewels are sold online only and personalized with a wrist measurement entered by customers. So what are they doing? They're using the semi-precious stones and rocks and things in the bracelets like the regular bracelets, but they're 3D printing the connectors, right, to the right size to make the bracelet the right size and the right fit. So I think this is really interesting. I wrote like a thing in 2009 or something about culminatory manufacturing, this idea that we would use the best of both worlds. And this seems to be a good application for that. We're elevating 3D printing by using it in combination with these natural materials, right? Rather than making 3D printing the star, which is what everyone was trying to do before. And that's why I think a lot of people failed in trying to sell polymer jewelry. Now, before you think like this is kind of a comparatively silly news item compared to like rocket propulsion and in-space propulsion and all this other stuff. It's really important because we have to realize that Pandora, which is a Danish company that makes these kind of like these little bracelets, these bangle bracelets, is a $2.6 billion revenue company, right? That's almost like a fourth or fifth of our industry, right? And it has much better margins than most people as well. It's got one of the best margins in the luxury goods industry. I think it's north of 46% or something like this. So it's a really, really good business, a really nice business to have. And we have to realize that we're all spending a lot of time going after space companies and Toyota and Henkel and whatever big manufacturing firms. That's all wonderful. But at the same time, one jewelry company could really amount to being a significant chunk of our industry. So we should keep looking for new applications and new things. The other thing that's interesting about this is that this idea, well, the first time I heard of it was Studio Minala Meda had a Keystones collection in 2012. Um, and that Keystones collection was essentially they printed polyamide as well connectors, and then with wood and other materials, they can be made into different furniture items. Since then, we've seen this idea come back a number of times, like people doing facades for buildings and then 3D printing the connectors to have the facade elements placed in the right angles on top of them, or 3D printed custom bicycles where they're using just standard tubing, right? But then they customize the lug system and the angles of the lug system to make the geometry custom. So they don't have to print the whole bike frame, they just print the one item that is customized. So I think that kind of this paradigm, this idea of saying, okay, wait a minute, we can use 3D printing in combination with mass-produced items or conventionally manufactured things, and at the same time, we can use it to the very, very point where it's really, really important and really, really makes a difference. And then we can use the cheaper technology to make the other part. I think that's really exciting. I think that really takes a second look because people are thinking now, like we either 3D print a little part or we print the things that make sense to print and we print all of them. But there's lots more ways of working together with other technologies that we should consider. So there's another thing. The number one item of news for today is digitally manufactured plasma sensors made for satellites. This is a working group or a team at MIT, and MIT's Microsystems Technology Laboratories or MTL. And this news came to us from, it was widely reported, I think, but it came to us, so we got it from MIT's blog, or an un-MIT blog, I think. And essentially what they're doing is they're digitally manufacturing using laser cutting and 3D printing sensors for CubeSats, inexpensive small satellites. These are retarding potential analyzers. What the blog post, original blog post said is 3D printed laser cut hardware performed as well as state-of-the-art semiconductor plasma sensors that are manufactured in a clean room, which makes them expensive and requires weeks of intricate fabrication. By contrast, the 3D printed sensors can be produced for tens of dollars in a matter of days. So what we're seeing there is that that's really, I think it's really exciting. I think this is super exciting. Now, that's one thing. In and of itself, I think this is really exciting. The other thing is how they did this, and the how is also fascinating. They turned to a glass ceramic material that had the right properties for them, and because it could withstand all these temperature the temperature change in space and all this kind of stuff. And this material is called vitrolite. And what they did is they figured out a way to make vitrolite work in vat polymerization. And they 3D printed the material then into the right shape for the sensors. So I think this is a wonderful project, a wonderful research project. At the same time, the really interesting idea, I think, is that we have MEMS, right? MEMS is this micro electromechanical systems, these really tiny integrated little mechanical electrical pressure sensors or digital sensors, accelerometers in your phone, that kind of thing. But they have electrical components and mechanical components, right? Now, these things are great if you have a huge production run, if you're going to make a lot of them. But what if we had kind of like a more of a macro mechanical systems where we'd use 3D printing to make larger kind of sensors and other kind of assemblies, using 3D printing's ability to print complex assemblies in one go, and then we made these things in really short production runs, like 4 or 5 or 6 or something. So a sensor that would only be on, one rocket or only be on certain sports cars. I think this is a really interesting way to think about this, this kind of thing, and a really interesting way to think about this technology. So I'd like to thank you guys for being here today. I'd like to really, urge you to contact me directly or put a comment somewhere or something to tell us what we're doing and how we're doing and all that. And then that's kind of what we're up to and what we really enjoyed being here today. We had 5 news items. These 5 news items are happening at the moment, and we'd like to thank you very much for attending.